Alright, so let's talk about coordination chemistry. So, coordination chemistry is the chemistry of coordination compounds or complexes. So basically, coordination compounds are compounds of Lewis base and Lewis acid. They are actually formed when Lewis base is attached to Lewis acid by the means of lone pairs of electrons. So basically, Lewis base are also regarded to as ligand because they also have lone pairs of electrons. Lewis acid are acceptors, basically they are deficient in electrons. So looking at this example here, we have silver and ammonia. So ammonia here, the nitrogen in ammonia has a lone pair of electrons, right? So this lone pair of electrons serves as a means through which this ligand or Lewis base is attached to the Lewis acid, which is the metal here. So basically, it's always obvious. Ligand, in most cases, they have a means of attachment to the Lewis acid, which is the lone pairs of electrons. So this here, the nitrogen here that contains the lone pairs of electron, is basically the donor atom, right? So it donates this to give the complex. So recall that I said that the nitrogen here is the donor atom. So this concept of donor atoms brings about denticity. So denticity is basically, let me write it here. So denticity is the number of donor atoms. Let's put it there. Is the number of donor atoms through which a Lewis base is attached to a Lewis acid. Is attached to a Lewis acid. So in this case, the donor atom is nitrogen is 1, right? So this is a monodentate ligand. The ligand here is monodentate. So let's say we have Fe, H2O, 6 and 3 plus. So the ligand here is H2O. I mean the Lewis base here is H2O. So here the Lewis base here is H2O. So the donor atom is oxygen. It has 2 lone pairs of electrons, like the oxygen there. We don't need to start proving that. We call that oxygen is 2 and 6. That's 8. So the last pair, let's put it here, 1, 2, and this 1, 2, 3, 4, 5, 6. So the 2 atoms of hydrogen are attached to these 2. That is, we have hydrogen attached here, hydrogen attached here. So we have 2 lone pairs of electrons. So these 2 lone pairs of electrons are means through which this ligand is attached to the ion here, right? So basically, oxygen here is the only donor atom in this ligand. So this is also a monodentate ligand, monodentate. So other examples of monodentate ligand are chlorine, so which is, we call it chloro. So we also have bromine, we have iodine, we have all of that. So but then we can also have ambidentate ligand. Ambidentate ligand, they have the ability to bind to the Lewis acid through 2 or more possible donor sites. So let's put it a ambidentate, right? Ambidentate ligand. So one example is NO2. So basically, the donor atom here are nitrogen and oxygen. That is, the ligand. This ligand can actually be coordinated to a Lewis acid via nitrogen or oxygen. So if it's coordinated where just the 2, right, the 2 donor atoms, so we can therefore call this as a bidentate ligand. That's two means of coordination to a Lewis acid. So we also have SCN. So it can actually coordinate through the sulfur or through the cyanide. So we also have several other ambidentate ligand.